In this problem, we have to calculate the flow rate in the canal, and the cross-section of the canal is trapezoidal in shape. Hydraulic jump occurs in the canal, and the depth before the jump is 1.2 meters, and the depth after the jump is 1.8 meters. If we will draw the cross-section of the hydraulic jump, okay, this is the bed of the channel, and if this is the depth before the jump, and that is 1.2 meters, and this is also the depth after the jump, and that is equal to 1.8 meters. Okay, this is the water surface. The cross section of the jump, if this is our section 1 and that is our section 2, our channel is trapezoidal in shape, and this is the depth before the jump, and the side slope, we have the same side slope, and that is 1 horizontal and 2 vertical. Okay, that is 1:2. We have the same side slopes. For section 2, I have to copy the cross section and paste. The depth at the section 2, the depth is 1.8. So this is, okay, this is y1, that is 1.2 meters depth, and this is for section 2, the depth is 1.8 meters. Okay. We will find the discharge in this problem, and the bottom width of our channel is also given. So the width is also given, and that is equal to 4 meters. Okay, so first we have to determine the area of each section, the area of the canal, or the area of flow of the canal at each section. In getting the area of flow of the non-rectangular section for the hydraulic jump problem, we need to determine the location of the centroids of the section from the water surface. So our section here is trapezoidal, and it is easier for us to determine the centroid of the trapezoidal section by dividing this one into rectangular and triangular shape. The centroid of the rectangular section is located 1/2 of its height, or in this problem, that is located 1/2 of its depth. And for the triangular section, the location of the centroid from the water surface, it is located 1/3 of its height, or 1/3 of its depth for this problem. We will treat this one as our section 1, but since we divide the section, so I will make this one as my area 1 1. Okay, that is area 11, and this is my area 1 2, and also my area 1 2, because they are the same. Okay, they are the same area, or maybe you can say this is your area 1 3 if they don't have the same side slope. So we can make it as area 1 3, but in this problem, area 1 2 and area 1 3 are equal. Okay, so we have now our area is equal to, okay, that is area for section 1 is equal to area 1 1 plus area 1 2 plus area 1 3. Since area 1 2 is equal to area 1 3, so your area 1 is equal to area 1 1 plus 2 area 1 2. We will determine the value of the x. Okay, we let that one as x. Since our side slope is equal to one horizontal and 2 vertical, we have the same side slopes. We have 1 vertical to 1 horizontal to 2 vertical, or 1:2. Okay, so solving x, we have by ratio and proportion, when x is equal to, or x over y is equal to 1 over 2. So x, we will express our x in terms of y, so we have 1/2 y. Okay, so if we have y as y1, so your x is equal to, so x, we will let this one as our x1. Okay, x1, so our x1 is also equal to 1/2 y1. Okay, so for the area 1, for the area 1 1, that is the area of rectangle, that is equal to, okay, the base of the trapezoidal section is equal to 4 meters. So you have 4 times y. Our y is equal to 1.2. Okay, this is 1.2 meters. That is for section 1. For section 1. Okay, so we have 4 times 1.2 plus 2 1/2 area of triangle, 1/2 base times height. So for x1, since our y1 is 1.2, so we have here x1 is 0.6 meters. So that is 1/2 0.6 times 1.2. Okay, we will solve 4 times 1.2. Okay, 2 over 2, this can be cancelled out, plus 0.6 times 1.2. Okay, that is equal to 5.52 meters squared. So we have 5.52 meter squared. Okay, for our section 2, Okay, we will do the same for section 2. Okay, say the same section, that is trapezoidal section. We have to divide the section into rectangular and triangular section. So this is 1.8 meters in depth. So we have here, okay, this will be our section 2. This is our section 2, but I have to make this as my section 1 for section 2, and this is section 2, and that is section 2 of section 2, that is area 2, and this is the area of section 2, and that is the area 3 of section 2. So I have to write that one as 2, 3. Okay, the same side slope, we have 1:2. Okay, 1:2. Then for our x, this will be our x2, and this is also our x2. Then the bottom width is also equal to 4 meters. So for area 2, that is the sum of the area 2, 1 plus area 2, 2 plus area 2, 3. So since area 2, 2 is equal to area 2, 3, because in this problem we have the same side slope. Now we have the same side slopes. So if we have different side slope, we have to add the area, each of the triangle. So 8 to here is equal to 8 to 1 plus 2, 8 to 2. Okay, so again we will compute the x2. Okay, that is also equal to 1/2. So x2 is equal to 1/2 of y2, and y2 is 1.8. So x2 is equal to 0.9 meters. We will compute the area of flow of section 2. So area 2, 1, that is the area of triangle, that is 4 times 1.8. So 4 times 1.8 plus 2 triangles. Okay, that is x2, 1/2 x2. Okay, 1/2 x2. Okay, x2 is equal to 0.9, and the depth is 1.8. So we can cancel 2, that is 2 over 2. So we will compute 4 times 1.8 plus 0.9 times 1.8. So the answer for the area of flow for section 2 is equal to 8.82 meters square. Okay, that is for area of the section 2. Then we will also compute the area and its location of the centroids from the water surface. So we have area y1, yc1. Okay, for section 1, this will be our yc1. Okay, this is yc1, and this one is our yc12, c12, and this is also our yc13. 1, 3 for area 1. Okay, so area 1, the area 1 is 5.52. So, okay, so we can write this one. Area YC1 is also the sum of area 1, 1, YC 1, 1 plus 2 area. Okay, we have to simplify again. So, okay, this is area YC 1, 1. Okay, area 1, 2. Okay, area 1, 2 YC 1, 2 plus area 1, 3 YC 1, 3. So since this one are equal, so we can write YC1 is equal to Y1 YC1 1 plus 2 area 1, 2 YC1 2. Then we will substitute the values. So here for our area 1 YC1. So for the area 1, 1, we have the area 1, 1. This is 4 times 1.2. So we have 4 times 1.2, and the centroids for that is 1/2 of Y2. No, sorry, 1/2 of Y1. Okay, Y1 here. Okay, this is your Y1, that is 1.2 meters. Okay, 1.2 meters. So 1/2 of 1.2, that is 0.6. Okay, that is the location of the centroid of the rectangle. So we have 0.6. Okay, then plus 2. Okay, 1/2. That is area 1, 2. Area 1, 2, that is the area of triangle at section 1. So that is 1/2 0.6, because your x1 is 0.6 times 1.2. Okay, you have 1/2 times 0.6 times 1.2 times 1/3 of y1, which is 1.2, 1/3 of 1.2. Okay, that is 0.4. Okay, that is 0.4. So we will compute. This is equal to, okay, 4 times 1.2. Okay, again, 4 times 1.2 times 0.6. Okay, that is 2.88. Plus, we can cancel 2 over 2. So you have 0.6 times 1.2 times 0.4. Okay, you have 0.288. So, okay, 2.88 plus 0.288. So, the area, okay, your area 1, YC1 is equal to 3.168. Okay, this is in meter cube. Okay, next is for the area 2, that is area 2 YC2. So, the same for section 2, the location of the centroid of this is your Y2. Okay, that is YC2 1. This one is the location of your centroid. Okay, this is YC2 2. And also here, this is YC2 3. Okay. Okay, we have to add A2YC2. That is just the sum of area 21 YC21 plus area 22 YC22, okay, plus area 23 YC23. Since they have the same side slope, so the area is equal to area 22 YC22 plus area 23 YC23 are equal. So we can write our formula for A2 YC2 is equal to 2 area 21 YC21 plus 2, okay, area 22 YC22. Okay, so we have to compute the area for section 2, that is the area of rectangle, sorry, that is the area of rectangle, that is 4 times 1.8, okay, that is 4 times 1.8, and the location of the centroid from the water surface is 1.8 divided by 2, and that is 0.9, okay, plus 2. Then for the area 22, that is the area of triangle, so you have 1/2. Your x2 is 0.9, okay, and depth of flow is 1.5. So you have 1/2, x is 0.9, depth of flow is 1.8, and the location of the centroid from the water surface is equal to 1/3 of the depth. So that is 1.8 divided by 3, and that is 0.6. Okay, 0.6. So we have to compute this 2 over 2. This can be cancelled. So you have 4 times 1.8 times 0.9. So you have 6.48. 6.48 plus 0.9 times 1.8 times 0.6. So you have 0.972. So 6.48 plus 0.972. So the answer is 7.452 meter cube. So that is area 2 YC2. Okay, for the velocity of the hydraulic jump in a non-rectangular section, we can compute the velocity before the jump, that is equal to V1 squared is equal to GA2 over A1 times A1 YC1 minus A2 YC2 all over divided by A1 minus A2. So, we will substitute all the values in our formula, and this will be equal to G is the gravitational acceleration, and that is 9.81. The area 2, okay, the area 2 is equal to 8.82. Okay, that is 8.82. Area 1 is equal to area 1, 5.52. 5.52, and area 1 YC1, that is 3.168, 3.168 minus area 2 YC2, that is 7.452 all over divided by, okay, A1 is equal to 5.52. Area 2 is 8.82. Okay, so this will be equal to, okay, 9.81 times 8.82 divided by 5.52, okay, times 3.168 minus 7.452. Okay, divided by 5.52 minus 8.82. And that is equal to, okay, 20. This is V1 squared. That is 20.349. Okay, therefore, V1, we will take the square root of that. Okay, that is 4.511. 511 meter per second. So we have our velocity for before hydraulic jump will occur. And since flow rate is constant all throughout of your channel, so we can determine the flow rate by, okay, the flow rate in the canal, which is equal to area 1 V1. So the area of section 1, or the area before the jump, that is the area of the flow rate before the jump, is equal to 5.52, and the velocity before the jump is 4.511. So therefore, Q is equal to 5.52 times 4.511. So that is 24.901. Okay, 24.901 cubic meter per second. So this is our final answer. So you have to encircle your final answer, or you have to box your final answer. Okay, so I hope you understand this problem, and thank you. God bless.